special guest is Dr. David Kraus, a certified industrial hygienist. Dr. Kraus, thank you, sir, very much for being with me today.
Thank you, John. Thanks for having me.
We're going to talk about air conditioning in buildings and homes and schools and the like. But first, maybe you could help us understand exactly what your background is and what is a certified industrial hygienist.
Certainly. Certified industrial hygienists are occupational health professionals who pass a rigorous examination, have years of training and experience, and are certified under the American Board of Industrial Hygiene. We focus on safety and health in the workplace, how to recognize hazards, and how to keep people safe.
And are you with a private company?
I am. I'm the owner and founder of HC3 Consulting in Tallahassee, Florida.
Well, thank you so much for being with us. I know you are cited in a number of articles, and I'm delighted to have the chance to talk to you. So let me ask the basic question. Are the home air conditioning systems that we use safe?
Well, certainly. And certainly in this time of the hot summers, we don't want people turning off their air conditioning systems because heat stress will kill you faster than COVID-19. But we do recognize that air conditioning systems do move aerosols around a home. And if someone in the home is ill with COVID-19, those can be spread throughout the entire residence.
Is a central air system better for your home than individual window units? It's certainly a lot more convenient.
Certainly. Central air is more convenient and more efficient, but it does take room from air from every room, runs it through the air conditioning system, cools it, dehumidifies it, filters it to some degree, and then returns it to the other parts of the room. So it can, inadvertently, through its normal operations, spread the virus throughout the home.
So what can we do about that? I think most people do have central air these days.
Well, there's a pretty straightforward solution to that. If you have someone in the home that you're trying to isolate, someone who has tested positive or symptomatic, you want to keep them in a room and then consider installing a window unit, a simple Windows HVAC system window unit that can serve that room, shut off the vents to that person's room to keep the air from returning back to the rest of the room.
Are there particular filters? I've heard that you could use a stronger or better filter, but I'm not sure. Are they available for homes, or how does that work?
Well, you'd certainly want to consult with your heating and air conditioning contractor to see if your home's air conditioning system is sized, and can be modified to accept a MERV 13 filter or higher. Unfortunately, these filters are typically much thicker, offer more air resistance, and will not fit within an standard central air conditioning system.
You call it a MERV 13. What's that?
MERV is a rating system.
Okay.
MERV is a rating system for filters. The higher the number, the more efficient or effective that filter is. MERV 13 is the minimum size filter that can capture aerosols that contain viruses. So minimum efficiency rating, MERV, yes. Minimum efficiency rating, I apologize, I cannot remember that.
That's all right. I mean, we can all look it up.
Yeah.
But the bottom line is it's a rating system of your filters.
Yes, it's a rating system of your filters, and minimum of a MERV 13 to make any impact on viruses. So you want to make sure that you have a MERV 13 or better, but most home air conditioning systems are not sized or capable of managing that kind of filter.
So when it comes to the home system, then, what's your recommendation? Oh, here's the other question. I know that you tell me, but it's my understanding that the home AC systems just use the existing air in the home and just kind of recirculate it, as opposed to taking fresh air from outside and recirculating it. Is that correct?
That is correct. Most home air conditioning systems simply recirculate 100% of the air in the home, whereas a school or a hospital by code has to have essentially an open window inside the air conditioning system. where it brings us a portion of the air that it recirculates and mixes it with fresh air and then delivers it to the building.
By the way, I just looked up MERV, minimum efficiency, you're right, reporting value.
Reporting value, yes. I remember when that system was being developed, I thought, why did you come up with that name? Okay.
Yeah, maybe someone named Merv was involved.
Well, his name was Barney Burroughs, but he was a good guy.
Let me ask you about, so then the question is, if you have a central AC system in your home, when the weather's a little cooler, should you just open up your windows and let fresh air in? Would that be helpful in any way?
Well, when the weather is permitting, that certainly is a great idea. But what do you do in the meantime? One aspect that we are looking at is using high efficiency particulate air filters, HEPA filters, that are installed in standalone air cleaners that operate separately from the air conditioning system. So you let the window unit air conditioning system do its job, cool and dehumidify the air, and you let a separate standalone unit actually perform the filtration, and that can be much more efficient and cost effective.
Now, what about commercial buildings where people work? I want to talk about those, and then we'll talk about the public schools. But the commercial buildings where folks work, now, a lot of folks have not been called back, and there's concerns about those buildings. I've heard over the years of sick buildings that people get sick in. What are recommendations? What are the best kind of commercial buildings to work in?
Well, that sick building syndrome and indoor air quality problems have often been traced back to energy conservation efforts. So to reduce the amount of outside air that you bring in, that ventilation air, that's done to reduce the energy. And when you bring in less outside air, it reduces the energy and thus reduces the costs. The more outside air you have, the better off you are. The more diluted the aerosols that contain viruses are made, and the other pollutants in the indoor environment are also diluted and made less concentrated.
So traditionally, how often is the air changed in a commercial building?
Well, by comparison, most commercial buildings are around 1 to 2 air changes per hour. So that would be the entire volume of the space is effectively ventilated through and blown through the building once every hour, or maybe twice every hour. Your average home is around 0.3 air changes per hour. You go into a hospital and you may be looking at a minimum of 6 air changes per hour. And in your ICU areas, you're at 12 to 18 air changes per hour. So you can see that in healthcare settings, they have adopted this approach in using high ventilation rates to control infectious disease. And for the most part, it works.
Yes, if I read correctly, the CDC recommends at least 6 changes per hour in order to combat COVID. Would that be true for commercial buildings too?
That's part of the recommendations we're working on with the American Industrial Hygiene Association and the guidance document that should be released in the next week. Minimum of 6 air changes per hour, 10 preferably, and up to 12 in areas where you may have to have higher occupancy, such as control centers, call centers, conference rooms, training areas where you can't socially distance as well.
But that, of course, is going to raise the cost of energy for those building owners.
And practically speaking, they can't achieve it anyway. Those that are even installed in buildings cannot handle the amount of heat and the amount of humidity that would be in that outside air. It would make it miserable inside the buildings. The way you achieve an effective and supplement that air changes are through high efficiency particulate air filters. They're like your home air cleaner that may sit in the middle of the room or in a child's room with asthma, but they're much larger. Instead of being 300 to 400 cubic feet per minute, they may be 1,000 or 1,500 or 2,000 cubic feet per minute, and they can serve a much larger area.
Finally, Dr. Krause, if I could ask you about schools. You know, a lot of interest in whether our schools are going to be able to open or on what basis they open. Um, are there CDC requirements? Where are we with schools and air conditioning? Because in many parts of the country, and particularly in your part, you cannot open a school without AC.
No, no. Unfortunately, I believe that if the administrations and the local school boards do not consider engineering controls, such as we're talking about, high HEPA filtered air systems and increasing ventilation to some degree, this is a very reckless plan. Putting that many kids in close contact, even with washing hands and trying to distance. Uh, I'm sorry, it's not a very good approach. I've run the numbers, and for as little as $2.50 per day per child, you may be able to implement and install and operate high efficiency air filtration systems that can then, once this pandemic is over, be unplugged and rolled out of the place. They aren't capital improvements. They aren't a change in systems. They do cost money, certainly, but that's less than half of the price of an N95 respirator today.
Is this a system that you put in each classroom, or is this something that connects to the main system?
No, it would need to be installed in each and every classroom, each and every lunchroom, possibly even the hallways. It's the same type of systems that are used when lead is being abated or asbestos is being abated. These are filtration systems that are intended to protect the health and safety of people in all types of environments. They're even used in healthcare.
And are they available for lease, or will the school district have to buy them?
They can do either. Purchasing them creates a whole other maintenance and operational program that they would have to take under their wings, and they may not have the manpower, resources, or technical know-how to do it. So it's probably going to be, in most instances, best a leased program from a vendor who then maintains the systems.
But it is your professional opinion that America's schools are not really prepared in terms of their HVAC system, their air conditioning systems, to open up with students?
I've been doing indoor air quality assessments in schools for 25 years. And for 25 years, I've seen failure after failure in schools, classrooms, libraries. They can barely keep up with the budgets and resources they have under best conditions. At this point, we're putting the life and safety of our children, our teachers, our custodians, our administrative staff into a system that's on the edge to begin with. So no, I don't believe they're ready for this type of challenge. They need assistance, they need resources, they need technical assistance, and this needs to be made a priority.
Well, Dr. David Krause, thank you very much, sir, for sharing your wisdom with us. We really appreciate hearing from you, and I have a feeling I'm going to be back in touch on this and some other issues as well. Thank you, sir, very much. We are with Professor Bill Baumfleth, our special guest today. Professor Baumfleth is get the correct title, the Professor of Architectural Engineering at Penn State University. And Professor, I've seen your name in a number of studies and scholarship articles. Thank you, sir, very much for talking to me.
Yeah, my pleasure.
So let me ask you right off the bat, what exactly is an architectural engineer?
Now, architectural engineers are the engineers who do all of the engineering associated with building design. So we often work with architects, but not necessarily with them, to design things like the heating, ventilating, and air conditioning systems, the structural systems, lighting and electric power systems, all of that technology that makes buildings work. And also our department has a construction management group. It's about process. It's a fairly small discipline in the US, but one that's highly recognized by the industry, and graduates of architectural engineering programs are coveted by industry.
Well, that certainly should be true in days of coronavirus, because I want to ask you about our buildings, our homes, our schools with respect to their safety and health. as a result of the HVAC systems they use. So if I may, Professor, start with our homes. Many people have home air conditioning systems, central air for some, for many. Others have window units. Is it safe to have air conditioning at home?
Oh, I certainly think it's safe. Is most people to begin with are with people who are in their bubble, so you probably can be pretty confident of the health of the people that you're with and what they're doing. Um, but the thing to keep in mind is that most of our home air conditioning systems do not bring in any outside air. So if you have a single family detached house with a split air conditioning system, the outside piece and the inside piece, that's just heating and cooling your house and circulating air inside of it. And even window units don't bring in outside air. Some of them claim to have an outside air vent, but they don't really do much as far as I've been able to tell from the research I've done. So to get air into most houses, you need to actually open windows and get air in that way, and then you get additional air just from whatever leaks in. So ventilation for most of our homes means opening a window and making sure that there's air flowing. So you may have to put a fan in a window to ensure that there's some air movement. When you get an infected person in your house, it's a different matter. You can kind of set up an isolation room in your house. You've heard of people being sent to the basement until they got better if they were recovering at home. You can also turn a bedroom or another room into an isolation room if you open a window, put a fan in, and use the fan to exhaust that room so that the air that's in the room that may have infectious material in it that the sick person is breathing out is going to be exhausted, and air will leak into that room from the rest of the house instead of from that room into the rest of the house. Those are, I mean, the main things to be aware of, I think, is that if you want outside air, you got to open your windows.
Well, let me ask you this first about the isolation. Could you actually turn off the AC, the central AC that goes into that room, and either cool that room through fans or put a window unit in there? Would that be your best recommendation?
A window unit to condition it might be a better idea than central air, although we don't have a lot of evidence that recirculating air has caused infections, and possibly just because the infectious dose of COVID-19 is relatively low. So if you have a sick person in one room and you take whatever infectious material they're producing and you mix it into a large volume, it may actually make you safer. But you can block off supplies from a central system or returns if there happens to be a return in a room that you want to use as an isolation room, and put in a local air conditioner and make sure you're exhausting the room. In fact, I have a colleague here in my department that asked me for some advice a while ago about how to do that. They're going to send the kids to the basement while they're home. They've got them set up down there with a kitchenette and a restroom, but the whole house is on one central air system. So we had to figure out how to do that to block off the mixing.
Yeah, I would think that'd be pretty important because we do know that coronavirus does transmit through the air, and while there may be minimal risks, there are risks.
Yeah, well, it does primarily, as far as we know, in situations where there is poor ventilation. So a home, since it doesn't have an outside air supply other than opening windows, is a place where the air could get pretty stale. I spent some time in Europe a couple of years ago on sabbatical in Denmark, and got very used to airing the house out several times a day. We did that there actually because they were concerned about humidity. They had lots of mold problems in buildings if they weren't ventilated. So it just became normal to open all the windows early in the morning when it was still nice and cool and air the house out for a while, and maybe do that another time or two during the day. So that's not ideal, but it's a practice I'd recommend. And actually, I'd recommend it even not during the pandemic, because it'll make your house a lot fresher if you do that regularly.
Yeah, let me ask you to restate that again, because I think that actually makes sense, which is that even in these hot 90-degree days, there is a time of day when you could open all your windows up. I don't know, how long should you leave them open before you turn your AC back on?
Uh, I leave them open as long as I can. When I start to notice that it's no longer comfortable inside, then I think about turning the AC on. That was the amazing thing we learned when we started doing that, was in our climate, how little in a house you really needed to have air conditioning to be comfortable. And we use it a lot less now than we used to.
On the other hand, particularly for certain kinds of age groups and people with medical conditions, none of this should lead to a recommendation that you shut down your air conditioning when it's 90 degrees out there, I take it.
No, yeah, for the most part, air conditioning doesn't pose a big risk, and especially for someone who's older and maybe more heat sensitive, that could be the biggest danger. I'm sure you remember after the hurricanes in Florida a few years ago, there was a case where a nursing home had a power failure and couldn't run its air conditioning, and 12 people died because of the thermal conditions inside. And we certainly don't want people being afraid to run their air conditioning and having much worse consequences.
Yeah, Professor, let me ask you about filters, because our central air conditioning systems, I guess even the window units, they all have a filter of some sort. Are there better filters that would protect us from coronavirus for our homes, or are the systems not built for that?
Well, window units, I wouldn't expect to have a very good filter in them, and there's probably not much you could do by trying to actually upgrade a window unit filter. And in that case, if that's all the air filtration you have, then you might consider portable HEPA filter units as a way of cleaning the air. And that's another general recommendation. If you're going to have to keep your house buttoned up some of the time, that's a good way to compensate for that. But for a furnace air conditioner, more of a central system, it could be possible to upgrade that with a considerably more efficient filter. And we mean by that a filter that not only removes more particles, but more smaller particles. The MERV rating system is something that almost everyone has heard about these days, minimum efficiency reporting value. You don't need to know the details except that filters are tested at different particle sizes, and there are minimum requirements for different particle size ranges. So a typical home might only have a MERV 6 filter in it, which is a pretty low efficiency filter. The numbers get larger, the filters get better. What my professional society, ASHRAE, is recommending for all buildings is that if you're able to upgrade your filter to MERV 13, that's a very good thing to do, both for protection from COVID-19 and also because fine particulate matter is one of our biggest indoor air health risks, and MERV 13 filters are good at removing that stuff that will cause lots of other health effects besides transmitting infectious diseases.
Very, very helpful. This is getting me interested in checking out the AC system in our house, because I'm not sure what kind of a filter we have, but you're suggesting MERV 13, or as close to it as you can get, would be the best.
That seems to be fairly optimal in terms of infectious disease risk reduction, and it has been shown in some studies to give a fairly significant improvement in terms of overall health effects from better air quality.
Professor, let me move on to the office buildings where we work. And many of us work in these big buildings that have centralized air systems. And I've heard over the years about so-called sick buildings, where the air systems are such that you're prone to get ill, particularly in the wintertime. What's your sense of our buildings? Are they safer? Is the air conditioning better or worse there than at home?
To some extent, I suppose it depends on the vintage of the building. We went through a phase in I suppose it was the 1970s into the 80s, where we were really concerned about energy use of buildings and energy cost. And one way to save energy in a building was to reduce the amount of outside air that was required of the standards. And so the design standards went down to very low levels for a while. And that was about the time that we started hearing reports of sick building syndrome. Sick building syndrome means that the occupants experience a range of symptoms when they're in the building. A large fraction do. There's no known cause, and the symptoms tend to go away when they leave the building. Normally, when those have been investigated, the main thing that they find is that the ventilation was low and that increasing the amount of outside air will help. But it can be other things as well. The way buildings are built now, different materials, they may have less tolerance for becoming wet, and you have more buildings with mold problems in them than we used to. But in general, an office building designed to the current standards should be a safe, reasonably healthy place to work. But the problem is always maintenance. How well is the maintenance done? And is the system actually doing what it was designed to do?
My understanding is that the HVAC systems in these big buildings are designed, unlike our homes, they're designed to bring in fresh air, but it's not like a lot of fresh air. Tell us what's going on in this area.
Well, the standards that are used to determine what the outside air quantity should be for a building are based on a certain requirement per unit of floor area, because the building itself produces contaminants, the carpeting and adhesives and all these things that are paint on the walls can produce emissions. And then there's a certain amount per person, because frankly, one of the biggest sources of pollution in buildings are people. And the amount of outdoor air that's required to a great extent is based on tests where people were put in a chamber and exposed to their own bioeffluent, their personal pollution at different ventilation rates. And you take a poll and you set the ventilation at the level that 80% of the people who are exposed with that ventilation rate think it's okay. So it's a perceived air quality standard, not a health and safety standard, although that's in the definition of acceptable indoor air as well. But that's how it's done. And it provides, I think, an acceptable level of protection against some diseases. But of course, we're looking at that much more carefully now, and I wouldn't be surprised if ventilation requirements go up in the future.
Is there a recommended air exchange? Should it be more than twice?
We don't think of it that way. As I mentioned before, the way the standards are written, it's how much floor area do you have in your building, and how many people are in this space, and you multiply the number of people by a certain flow rate and the amount of floor area by a certain flow rate, and you add them together, and that's the total for that room, and then add them up for all of the rooms, and that's the total for the building. And so the air change rates are something that people talk about, but that's not actually how the standards and codes are typically written.
And then finally, on office buildings, it's my impression, and you're the architectural engineer, so tell me what's true or false here, but I have the impression that many of our buildings have windows that do not open, that there's no way to really bring fresh air into the building except through the HVAC system. Is that right?
Yeah, that's true for many buildings. Most of these glass towers you'll see when you walk around an urban area, they typically don't have windows in them, and you're relying on the HVAC system to bring in the outside air, and you hope that the calculations were done right, and you hope that the system was maintained. And I think, in the future, probably we'll see a lot more attention paid to maintenance, because people will be asking.
Well, that leads me to the final kind of building that a lot of folks have concerns over, and that's our school buildings. Both public, private schools. Now, some have windows that open, some do not. Some have air conditioning, some do not. But in general, as you have followed this debate over whether our schools should open or not open, or open partially, generally, Professor, what's your view of the health safety of our buildings for school kids, given coronavirus?
Well, there's a huge range of building types and conditions in schools. It could be the 100-year-old building with operable windows. It could be the one that was built in the 1960s that has fan coil units and operable windows, or it could be a very modern school that has a central air conditioning system and no operable windows. I went to a high school in Ohio that didn't have operable windows. So just about any type of building design you can think of might be a school, and those buildings have the same issues as other types of buildings. Some of them, it's much easier to get more outside air into them in a reliable way. Some of them have the ability to upgrade filters more than some others might. And so I think you have to look at them case by case. I think the toughest thing about going back to school is just having a lot of people in the building together, especially if we're talking about changing classrooms and factors like that may contribute to risk. I think there are ways of keeping the risk that might be associated with air conditioning moderate, but there are a lot of other factors as well. Of course, we've been dealing with that at Penn State all summer as we try to figure out how to go back into the classrooms, but it's going to be a very interesting fall semester with distancing and all of the rules that have to be followed to get people into and out of classrooms and disinfecting every day. There are a lot of things beyond just the air conditioning that I think are making that a challenging prospect, although we need to try to do it.
I get the feeling, Professor, that as somebody who teaches in a classroom, I presume with students, usually fairly close by, you're more concerned about other issues than you are about the air conditioning at the university?
Well, I think there is a reason to be concerned about some of our buildings because we have a lot of old buildings that are only ventilated by opening the windows, and sometimes the windows don't open. It just happens. We haven't had to think about this for years, and if a window is painted shut, or that wasn't a big issue until now. But I have some concern about it, and frankly, to be honest, I'm doing my lecturing remotely this year. I'm going to record lectures and have online meetings with students, and I have teaching assistants who will go into the classroom to have in-person meetings with the students, and I'll try to arrange some other activities as well. But given my own age and risk factors, to be honest, it's probably prudent for me to minimize the amount of time I spend there.
Well, you will get absolutely no challenge from me because I have the same age risk factors, maybe even more so, judging by my gray hair.
Yes.
And you're not so gray. But Professor, it really is a pleasure to have you with us. Professor Bill Bonfleth from Penn State University. Thank you, sir, very much for sharing your knowledge and expertise with us. We really appreciate it.
Yeah, my pleasure. Thank you very much for having me.
Just because the weekend starts doesn't mean our commitment to excellence stops. Wake up to KDKA TV News Saturday and Sunday morning for overnight and breaking